In this video, we talk about data encapsulation in TCP/IP model. First, we talk about the roles of software application, then we will go into detail on data encapsulation at each layer of TCP/IP model. Finally, we sum up our video with the keynotes. As you know, software application is not part of TCP/IP model. However, the application itself plays an important role in triggering TCP/IP model to function. When an application generates requests sending data to another computer, it actually triggers the data encapsulation process. First, it specifies which service it will consume from application layer. It then informs network layer the destination IP address that it wants the data to be transferred to. Finally, it hands its data to the application layer. In conclusion, the data encapsulation process happens at the host sending data. Let's talk about the application layer. As soon as the application layer receives the data from the application software, the data encapsulation process begins. First, the application layer performs its functions such as data conversion, compression, and encryption. It then attaches its header into the application data. In TCP/IP model, everything from the application layer is called data. All the data is then gets moved to the transport layer. Upon receiving the data from application layer, the transport layer segments it into small pieces to put into its data field. To instruct how the data must be processed, transport layer attaches its control information to the data along with the source and destination ports. In TCP/IP model, everything from transport layer is called segment. The entire segment is now passed to the network layer. Before looking into data encapsulation process at network layer, let's see how the transport layer gets its port information. Let's analyze the network diagram where the client computer opens Cisco skill website. The transport implementation software generates a random ephemeral source port ranging from 1025 to 65535. In this case, it generated port 4915. Since it is connecting to a secure website, so it knows the predefined port for secure website is 443. Therefore, the destination port is 443. Now, at the web server returning Cisco skill web page, it knows the source port is 443 for secure web service that it provides. It also knows the destination port is 4915 that it learned from the client. That is how the transport layer gets the port information. Let's continue with the data encapsulation process at network layer. Network layer considers the segment received from transport layer as its own data and does not touch it. To instruct how the data must be processed, network layer attaches additional field into the data. It uses the protocol field to identify which protocol in the upper layer generating or consuming the data. Finally, the network layer gets the IP address provided by software application as the destination IP and uses the host IP as the source IP. In TCP/IP model, everything from network layer is called packet. The entire packet now is moved to the data link layer. As you know, the data link layer considers the packet as its own data. It then attaches the control information to the packet. The data link layer uses its ARP protocol to find the destination hardware address and uses its host hardware address as a source address. It then calculates the data checksum and put it into the chiller called frame check sequence or FCS. At the data link layer, the data has the header and also the chiller. Therefore, it is called frame. Finally, it puts the frame into the Y at physical layer for transferring, which completes the data encapsulation process. Let's sum up our video with the keynotes. Software application is not part of TCP/IP model. However, it triggers the data encapsulation process in TCP/IP model by requesting to send data. The data encapsulation process happens at the host sending data. When the data flows down through each layer in TCP/IP model, it is encapsulated with a header. Only in data link layer, the data is encapsulated with a header and a channel. As a network engineer, we must know the name of TCP/IP message at each layer listed below. At transport layer, it is called segment. At network layer, it is called packet. And at data link layer, it is called frame. This is the end of this video. Thank you very much for watching.